Exponential probability distribution describes the time between events in a Poisson point process. So that would be a process in which events occur continuously and independently at a constant average rate, may be viewed as a continuous counterpart of the geometric distribution. So in queuing theory, the service times of agents in a system, or for example, how long it takes a bank teller to serve a customer, are often modeled as exponentially distributed variables. So since time is never a negative value, the exponential variable is always going to be a positive value. This chart is going to show us three exponential distributions. The graphs start at the value of lambda, where the random variable's x is 0, and then it declines steadily as we move to the right with increasing values of x. Compare the shapes of the different exponential distributions as our lambda changes from 1/3 to 1 and then to 2. With continuous distributions, we do not find the probability that a particular value of x occurs, but rather that the probability that a random variable x occurs in a specified interval. The area of that time interval under the curve is the probability, and rather than use a table, we use a formula. So in this formula, we have E, which represents the constant 2.71828. And the mean and the standard deviations are going to be equal in an exponential distribution. So here we can use that formula to find the probability with a lambda of 1/20 and x equals 5. We can then conclude that there's a 22% chance that the next order will arrive in less than 5 seconds, and we will see this in the left tail area of the exponential distribution. When we wish to find the probability in the right tail area, you can then use your formula to find the probability an order arrives in less than 40 seconds, and then use the complement rule. But if we do 1 minus parentheses 1 minus e to the negative lambda x to get e to the negative 1 lambda x, so we can just go from there. So here we might find the likelihood that it would be in 40 seconds or more before the next order is received at the pharmacy being 13.5%.